I've been hanging out with Hades for a bit, but information is beautiful. So we need, if given a duo boon, we need some way. And I guess I don't even. Or I think I was just going to try drawing lines just to see if we identified everything correctly. Although I still have to be able to draw the lines, so. So. And do I need. So my traits is still God index. The duo boons are. I think they're technically only listed under one god, so like even having it. It's like if it was indexed under both gods, it would be at least marginally useful for drawing their own connections. If I had a traits thing, and I had some way to get duo boons or duo boons for a particular god, then we could maybe swap that out. Now it's a public implementation right now. That might be a little bit of trouble. Did I already? Let's see. So we have God name. We have identify boons as a utility function. We're actually going to go through and make a new data structure. And I might yet want to do two sets of data structures here. An import format and a use format. But if we just had a way to get duo boons, and this is like all support stuff for identify boons. Some of this stuff, maybe there are. Well, this is mostly identify stuff. I also want to make this on module, but we might be able to use some iteration things here. Maybe we stick this above. So we want to be able to get all of the duo boons. And you're just going to be a list of, we call these trait. Yeah, which have a boon type. So we have to do, well, this would be if it's for doing the ones from each god, that would be a cat map though. And I guess I could actually, we could actually do these ones as, it's just the list.map function. Is God data. And this is just god.traits. Well, these would only be in linked upgrades. Is there anything special? No, just list trait. And this would just be a filter. This is actually a pretty simple function, but maybe it's one we could potentially reuse later. Actually, we only care about boon type here, don't we? No, this contains the gods, so we cannot do an equal on it. So our boon type was unknown, basic, and duo. Yep. Oh, no, we called it data. Okay, so that's all the things we want to go over. Yeah. No, those will reference gods. We then need to have some way to look up where that is. And since I did a custom type, I can't do a dictionary. I mean, I guess I can just do a function that we have. This has the order. Oh, this has the order by strings. How did I end up ordering this? Or did this get reordered? Well, my notes got all scrambled here. Oh, we've got our order. Aphrodite, Ares, Demeter, Dionysus, Poseidon, Dina, Artemis, Zeus. Is it in that order? Because I used this to make the type and the... Or did I sort by... Why are you in that order? Yep. That was searching for sort. Oh, no, I did something in the data export to output them as a list in that order. So if I want to be able to go from a god to a position, or to an index, I need to have... I basically need to examine my list. figure out where you are, which I guess if we just have the traits of gods. And maybe some of that stuff should be part of traits. Although I guess I can kind of, I was originally putting the order here because like, oh yeah, that's a layout concern. Maybe index is kind of a data thing. So given an index, I should be able to calculate a location. I guess we just have a way to get an index for now. If we want to make it more efficient later, we can. Could actually make that a little module. I don't know if it's really worth it. So we got all that stuff. So how do we do that? Oh, and a particular god that, yeah, this is where naming gets hard. I guess I would sometimes like display blah 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 to help identify the view functions. So we know we have to drop one. We have to go through, we have to test their god property. Now, look, well, I could look up a particular god from a list in traits, but that wouldn't necessarily give you the index of it. We could map them to a list of with index. But then you have to go and pull it back out. You could do the recursive type of search where you just increment and test, increment and test, increment and test, increment and test. That should at least be able to short circuit return once it finds something. Maybe for the drawing purpose, these should actually be an array. I don't know if we can... Maybe get the index of an array? The initialize repeat from list is empty length get. The element there. Yeah, there's not a... I don't know if there's even a remember operation. And you would almost need like a helper function. Oh, how do we deal with end of list? And we can lie. We believe that it, well, if we were looking it up by the lookup table, and I guess at the view layer, that we could just define the lookup table. It's not data-based. But since we did the enum, and we don't even need traits. This is just a different version of having that order list. Oh. But Hermes is in there. Well, if it'd be 0 to 7, you'd be 8, I guess. All right, so that means the other thing we need is, so there's two ways to go about this. One is, I think there's ways in collage to get the final coordinate of something, and the other is we actually just calculate the point. And I think we might need to be doing some geometry stuff anyway. Now, needing to do a bunch of geometry stuff could be a case for actually bringing in a matrix library. In order to do that, we'd have to be able to get somewhere into the rendering process where we have gone through all of the traits, and see, those are just stacking the circle, collision rectangle, and gods themselves. So I have to get this as an intermediate value and then go ask for, and actually that would just be like a tuple list you'd have to iterate over. Unless you turned it into an array and did index of based off the index. That rather than giving you the angle would give you the coordinates. So either go from index to we calculate the coordinates. Or we try to get collage to tell us where it is. The nice thing about having collage tell us where it is as we move things around, it would stay synced up, versus if we try to calculate it, then we're going to have to make parallel changes to both the drawing and to the center calculation. Now we need another name. Yeah. I might need to get better names. Although interestingly, I don't necessarily need this index map anymore. But I guess it's there, so why not? Although if I switched it to this order, then it would give me a way to replace that order and do that peer view layer thing. Now in. All right, so what can we do with you? Now this might be like layout or render. Oh, to flip. That's to the edges. Calculate a point. There's top, top left, right, bottom left, base. Now this is going to be, remember I say transformed everything here? Ooh. Oh, did you return a single collage? Okay, you stacked yourself. But actually, this is an intermediate value. which change the declared type of that function, which changes the declared type of, no, only of this function. This is a very particular method of iteration here. Okay, those appear to be in some kind of unit coordinates with some very fidgety near zero cases. I guess if I had a function from index to location, that would be it'd be easier just to use that from anywhere. Now that is in, I might need to have that in an array. So I could take the index and look it up. It's either that or have to map it to a list of pairs so I can just iterate through and look it up. Man, this enum versus array thing is awkward because it's like if we have a god, we know we can. Well, I guess Hermes isn't here necessarily. So we know that value is going to exist. Do we have to import array? And I might need the type here if we're passing this around. All right, so if we iterate through duo boons and we give that the list of center points, we should at least be able to draw a line. I might end up needing some other guide information here too, like if I want to do colored lines. Is it trait or traits? Traits. Now my display, that one's returning a list because it needed a list. I guess I could have this also return the centers. All right, display god index is kind of a helper. You are going to be a list of trait a array of point, and you're going to give me back a collage. If we just do this as lines, I guess we start off by just, let's see, that is the list. We are mapping over you. Oh, I don't know if I want to rotate these. I might end up rotating the individual gods, means I need to rotate the duo boons. I guess we can solve that later. That would mean rotating each thing to an individual position and then drawing it. Which might be a very different thing. Oh. You know, this probably should be the other way around. It's like extra information. This is like the thing that we're actually doing. So we have the centers we can use to look up the centers for both of the points that are on here. This would be a kind of path, right? Yeah. Oh, horizontal line. Okay, or segment. I guess the horizontal line is if you're doing a transformed system. But in this case, these will eventually be arcs, so it'll get more complicated. Okay, so we know it's a duo, but we still have to switch to get the gods out. Is there like a collage.none? It could be an empty group. That's a little bit unfortunate. Okay. So we want a segment from, I guess we need like God center. This actually might be kind of simple. Oh, this is going to be a maybe, though. Because ultimately the arrays, maybe we could have gotten Hermes mixed in there somehow. So we go who to God index. No, actually array. Get is going to want int array. Which and you're a maybe point. Do we just default this? Centers A. Centers B. I'm eventually gonna have to care about who's who, and I don't think that the boon data is going to be set up in a convenient way here. Centers trait. That's a maybe module. Array. Okay, so we actually left off array. And can we misspell segment? Oh, and I'm gonna have to like stroke this or something too. It's a path. Oh no, that's type. Okay, so segment. And we already drew a circle, right? Outlined. I have the right precedence. It expects shape. So it might have to do something special with paths. That makes a path. Turning paths into collages. Okay, the circle is a shape. Trace. So close makes a shape. This goes straight to drawn. It's a line style. So I think this is a line style. Oh, did I swap these and not swap these? Oh, what happened to Aphrodite? Did we mess up exporting her data, or did we mess up getting her coordinates? No, there's Aphrodite. I must have messed up. Oh. Oh, yeah, we messed that up real good. We started changing all the numbers. We changed them too soon. I guess that would have been going to 0, 0. Okay, so we have all the pairs. And that is basically how you would do it in a... This is sort of the default way to do it. The problem is, like, the place you'd want to put, like, the marks is going to be, like, just crossing so many lines. So I need to actually be looking at index distance to decide what kind of lines to do. Well, there's two ways to do it. There is... I'm going to take all immediately adjacent pairs, and I'm going to draw that line. But that means I have to essentially do a lookup on the boon. Or there is go through all our boons and figure out what kind of line to draw. Now, admittedly, going through the types would make drawing a lot easier because we essentially just do, 8-way symmetry. Well, see, these are... I might almost just do a point here for these. I guess on that front, where is... Display God. You're just a text. Right, we had to zoom it up, and then we had to make the... Yeah, we had really ugly text if we didn't do really big text size and that. Now, this is kind of a temporary thing. I guess what we need to do is we need to have a stack. And we got a circle, right? Now, is this area already locally scaled to the god, or is that going to be full size? Well, it's certainly pretty. And it might it almost cover some of the arts we want to do. Is the effective bounds of the graph, not of where we want the graph to be. I just turned it to collage. I would have to do a thing that's both, right? Or debug outline that square. No. Although the scale might be a little bit weird. Yeah, the scale's a little bit weird. All right, we're going to switch back to that at some point. So, styled, fill style, line style. I guess technically this takes care of the inner parentheses from having the tuple boundaries. And then we could actually do something more like debug. So outlined is a line style. So we had is that uniform? No, that's not uniform. Oh no, that's okay, that's fill. So solid versus that's custom dot dash dash dot. I have to look what colors I have too. Is the zooming weird with the dots? Still seems pretty solid to me. Yeah, it might not like. Oh, okay. Oh, this is completely custom distances. I actually need to be small things here. Oop, nope. We don't. It's not a type. No. Oh, no, it's a list of pairs. Okay, that's a little bit weird. Oh, you're integers. No wonder it doesn't work. Well, it's just dot. Yeah. We tried. Your dots are too big. Maybe the dots are like 1, and that's 1. I guess this is still a special thing, because that's where it would normally be. All right, now. I guess this would be exactly... Well... It would be the perimeter of the circle divided by 16. And technically it would depend on the total number of things we had. We have the number here. You don't have... No. And I don't do geometry enough. I could probably work it back out. Two pi r. Perimeter Let's see, so this is going to be of the radius of our main circle, which we need to make a parameter somewhere. Or is it just pi? Okay, it's lowercase pi. I already did tau. Wait, what did I do with tau? What's the rotation factor? It's not quite the same things we need. At least I could probably translate that back into what we need. All right, so the size of this circle is going to be the perimeter of, when I say the perimeter of, well, it's a unit circle. Which actually makes the tau is just the perimeter. No, it's a 0.9 circle. Currently. Or was that that's the outer circle. What is the, no, it's a 3.5, so that's a 7. And it's a radius. Hmm. I ended up in exactly this, maybe not exactly the same spot. Okay, first of all, is this doing what I think? Oh, maybe because this is relative to the God scale? No, that can't be relative to the God scale. Which means that these aren't in 1x1s, which, I mean, maybe that's just too hard to do. Yeah, I'm not scaling you. I don't know if scaling you works nice. What do I want to scale you to? Because ideally, I'd do this in a unit circle. And then, oh, then I'd do all this relative sizing stuff. Maybe maybe there. I won't need to count. Now, because I was just kind of arbitrarily sizing the text here, I mean, I guess the rotate doesn't matter too much. Oh, that must be the outer. Okay, so that's actually too big. circle 1.0. Well, okay, you were 0.5, or you were 0.45 to be in a little bit. You might need to be there or very, very close to there. Okay, so that's gonna be a little bit too big. Wait, I did some browser zoom too. That's why I keep getting big. Of course, this is just the stand-in text, but is this? I guess that would have been half, right? And might as well be actually bumping the edges, so maybe having that drop to the edge would be kind of okay. And then that was well, like I was kind of doing an arbitrary amount that looked good. And then I think we just kind of undo all of this. And we'll need, I guess we'll need more elements here eventually, but we won't need this per se. So that'll go into how we scale it, actually. So what are you? Is that... No, there's all the little circles. What are you? They're all the little circles, right? Oh, did that affect how the shift is scaled? So because this thing is scaled down, maybe? Oh, okay. That looks about right. Huh. What unit is it? I guess this was applying to the shift. Then we have to rotate after the shift. Well, this matches the model I'm used to for these. All right, now this would actually be within. Now I have to compose this. Now, no, wait, I was just trying to do a unit circle. So this has to, right, these are not necessarily going to touch that outer circle. That was just kind of an arbitrary guideline, and I don't know if I put these in the right spot. So really this is going to be not the circle, but the scale of that thing. You. That might actually be okay. Unless we wanted to calculate the actual intersection point and get that distance. Because technically, I think they're meeting here, which is the... Well... There's like the left, right, and then they're rotated from there, which brings this closer, but it's still the straight line, which is... Yeah, that would have, like, deflected the straight line point between them. You know what? I have to calculate this intersection anyway to be able to put the duo boon there. And this whole thing's going to have to be a lot smaller to allow for the arcs. So how do we calculate that? I kind of need the midpoint between any set of gods here. I'll just put the midpoint of the line, and then half the length of that. But I'd have to have... Oh, we're going point to point. You don't currently have centers. In fact, I calculate centers from the stuff I'm drawing here. This might be an argument for calculating it instead. Well, actually, yeah, this is actually kind of just trigonometry. We can figure out this angle, and we have two sides of the triangle, which I think fully constrains the final side. Yeah, see, these are calculators. I need the formula. Let's say a regular triangle. One angle and the other four unknowns. Must be... That's the length of one side of a right triangle. It's a regular. Well, I sort of need a solution. I need a formula, though. There is a particular type of triangle. I guess, would that be equilateral? As a calculator, I need the formula. Oh, and actually, this is one of the sides I need. The length of the height. Okay, so 2x, square root of 3x. Is x the other side, though? The area. 2x is the length of a side. The length of which side? The length of a side, the base, is the length of the height, is x square root of 3. And then the area gets worked back into the triangle? If A equals, I actually... Oh, equilateral. No, this is all three sides. This is not quite equilateral. What does two sides equal? Isosceles? Okay. Isosceles? Calculator. So we have the angle for the equal sides. We have the equal sides. The length of the equal sides given the side base. Length of a side base given equal sides and angle. I guess this is the formula and this is the simplification? Or is that given the other angle? And yeah, A is the other angle. 2a sine b divided by 2, or a square root 2 minus 2 cos b. All right, so we have like math, cos, sine. Which one is going to be easier to? 2 times length of side times sine b divided by 2. I guess in terms of like fancy math operations, we've got a cosine and a square root versus a sine. And the rest is just multiplication and division. All right, we probably need to pull out some constants here. Well, although I guess it's been convenient to have these things in here for fidgeting. But we need to know the radius of the circle the gods are on. I guess the angle will be the same regardless. The angle is... This is where we needed to know. Angle in radians, which, hey, what do you know? That's what tau and stuff is. So that is going to be All right, so this wasn't exactly what we needed. I mean, put you in for now. Factor is the amount we. Oh, that's the exactly the amount we rotate each god by. So that's our angle. Now this was in fact was divided by 2. And then the length is 0.35, I think. We've got tau, we've got... Maybe we do a local variable for now. I don't know if the units are going to work out here. So that we can do... What the heck is this? So this is the entire side of the triangle, which is 2 times. We only want half of it. So radius is the length of a side. Times sin of factor. And that would just be our scale, right? And that was, what, half is the radius? Apparently that's negative. Oh, because I wanted to rotate this in reverse. Okay. No, and we need the rotate. Okay, well that was... the amount we rotate by. That doesn't even feel like it's half. Because maybe my radius... Oh, no, that actually worked out perfectly. Even though... Oh, and it could reason it as scale, not as radius. Okay, so currently we're iterating the boon lines. As boons, we would need to figure out, we would need to classify it by the inter-index distance. Now, the point-to-point worked well for lines. I might actually want to be going to, like, be thinking in terms of, like, angles of rotation in terms of drawing some of these things. Because, like, this gave us a very nice formula for that, but that kind of relied on knowing what this geometry was. All right, so these, I'm not even sure I'm going to draw lines. I might just put the symbol here and then do the connections within the God charts. For now, I guess we can draw a line. So we've been displaying duo. Given the centers and the trait, which can get the gods can get the indexes, we could figure out angles if we needed to. So that's getting the index, looking up the center, and drawing a line between it. So that's nice in of itself, but I need to do... Well, I guess I've got God. I could define a table of all the duo boon ABs that said what kind of arc to draw. Be kind of a pain, we could do it. But that wouldn't hold up well if I ever wanted to reorder things. So we want to figure out like the adjacency level of two gods, which means looking up the indexes again. I don't know if distance is the right word, but... And now I'm wondering if I should classify this as numbers or as an enumerated type. Because I'm basically going to be switching off it anyway. Although it is going to kind of come down to, what, like 2 adjacent, 3 adjacent? All right, so skip 1, skip 2. Now, we've got, with 8, they're opposite. I guess everything else is going to be opposite if we have to just classify stuff. All right, so we want... Well, just the adjacency level, and I might want to deal with sign at some point. I also have to deal with rotation. And in terms of who we consider left and right when drawing, So if we do any two gods, it could be 1 or -1. I might try doing a modulus to take care of those wraparounds. For classification purposes, I guess we just do the abs. Abs and... All right, so there's two operators here. Modular arithmetic. Okay, this is treatment of negative numbers. Remainder by 4, -5 is -1. Oh, mod by 4, -5 is 3? What does that mean for our case? Well, okay, so 0, 3... Well, this probably is what we want. Because we wrap around negative... Well, no, if it's -1, we want... Oh, no, this leaves us with a negative number. Well, or do we just abs it and then take care of wraparound? Would a -1... No, -1 is still one distance. Oh, the problem is if we do, like, 1 minus 8... we get -7, and we want -7 to become 1. So mod by might actually be it. Mod by count. We need some kind of parenthesis here. All right, 0 is an error. And anything else is opposite. Which I guess we could kind of leave 0 in that class too, because it's not really supposed to exist. All right, and then we can define so right now those are going to be the same. The adjacent might be a little bit different. You need any other information? You need centers. And display opposite is going to be the same. I guess this could be one switch function, but kind of wanted to factor these out a little bit. Maybe I was thinking originally, I was thinking I'd reuse this. Should you have the same signature? You might need centers. I guess we've got some structural stuff to do, so we're just going to do like display adjacent. And you are totally busted. So, case, got adjacency. Is it AB? Do I need anything else from you? Skip one. I guess one thing I could do is change the colors. Let's just, it says that's actually going to be, what color package do we have? AV4H. For the readily available ones. Eight shades of gray. Oh, that's kind of what I was thinking of. So this is going to be maybe even dark gray. Well, because I'm just booting to this, I can't actually do anything different there. Got adjacency. Oh, we need the count. Which you don't have. Except by inference. Oh, you're an array length. Okay, yes, all of those, we're reusing these. That looks very wrong. Let's finish out the colors so I can actually tell what's going on better. Oh, that is completely wrong. Maybe mod by wasn't it? Okay, so for gods. Gods A, B with indexes. Yeah. We have a difference. This is where I probably should have started from my other code and worked it back down. Yeah, the debug log still needs that. And a mod. Okay, so Zeus to Artemis. 7-6, difference 1, mod 1. That's gray, that's right. Zeus, Poseidon, 7-4. Difference 3, mod 3. I went blue, okay. This must be the negatives. Athena, Zeus. Now you see, this is bogus. 2 was the right answer there. I guess there's the concern about wraparound. But for this simple case, yeah, that's garbage. Does this fix it? Or do I have to do the abs? Well, it definitely doesn't fix it. Okay, diff 1, mod 1, diff 3, mod 3, negative 2, 6? Yeah, let's get compiled. So neither of them are right. Wait a minute. This is not... I don't feel like this is following the code examples. Negative 1, negative 2, negative 3. It should leave those alone. Oh, because I didn't change that. Negative 2 to negative 2. So this is Athena, Zeus. That should not be a white connection. But now we have to do the abs. That might be right, except for the wraparound. And I wonder if mod by abs is what we want. Poidon. Okay, just too many. Nope, that gets the same effect as remainder. I guess remainder was simpler. Oh no, it's not the same effect. Maybe I still had to throw the abs in there. And I can't redo. Fabulous. Yeah, maybe that was the remainder. Oh, oops, the abs is in the wrong place. I'm amazed that actually worked. Alright, so I guess Zeus and Aphrodite should be sufficient to figure this out. 7, 0, different 7. Eh. But 7 is still a valid value, so you don't get the wraparound. No, I need to add and mod. Maybe? Aphrodite Aries is... Well, it's going to be Aries. But it'd be 1. Aphrodite to meter would be 2. Well, yeah, Aphrodite is easy. 1 plus 2 is 3, which is... not right. Or even 7 plus 0 is still 7. It's not a mod. How do I handle wraparound distance? Seems like when I know one time I did a thing where we represented circles as a byte. So 255 values, you mostly just added and subtracted and let the byte rollover take care of stuff. So so that's clockwise. Maybe I do have to order them first. Well, we always ordered. That could remove the sign issue. Would I then have to do some sort of mod by assuming the size of the circle? Maybe there's just not simple math here. So we do know that a largish distance is just going to be... it's not going to be this. Do we have to do like a modulus by half? And maybe one of those remainder operations. So that's the absolute. That gets rid of the negative problem. We had other problems when we did other versions of this, but... Oh, no, it would not be count. This would be like 10 divided by 2. Closer, but it's still misclassifying. Nope, those are equivalent. So it might be getting the wrong count value. So that's a blue. So that's a... Let's see. I want... There really should be no 0. I want 1, 2, 3, which actually should be 4. If there's 8, count divided by 2 should be 4. So what's going wrong with Zeus Aphrodite? So we didn't see any difference between these. We were throwing the count divided by 2 and the abs in there. So many parentheses. So you. Mod 3. Oh, divided by 4. No, that's not right. Maybe we do want sign now? Oh, you're positive, so that's not going to make a difference. And this is going to be wrong too. So 7, 0 should be a distance of 1. Let's work better in one base. That would be... That 7, 0, well, that would then become 8 minus 1. It's still 7. Now, is it by chance that Aphrodite Artemis is working out? -6. Difference of 2, skip 1. Well, that's a -6, which goes to 2. All right, so that actually might be kind of chance. Actually, yeah, this one's wrong too. Artemis Aries. Anything that wraps around. Do I just have to treat anything? Oh, man. If there was any god in the upper half, do we have to treat them differently? Let's see, if we turned it around, it would be -7, which I don't really think would make a difference. Well, because we're absing, so yeah. Toroidal space. Well, this is a full. Minimize each axis individually. Calculate distance. Do we take anything in the upper half and turn it into negative numbers? Well, then you'd have a crossing point at the other end of the spectrum. Minimize each axis individually. Okay, so that makes it dimension-wise. That makes it 2 cases. Well, maybe 3 if we count the core. Six cases instead of 9? And maybe you wouldn't have to do 0 twice. It would be 5. So we would do this twice and take the smaller one? Right, I guess there's some truth to that. Try each direction around the ring and see which is better. Absolute value of the 1D distance is greater than 0.5. The real distance for that axis is 1 minus distance. We got a 3. And we got a 7, which is greater than half. The real distance would be 8 minus 7. So we need to do an intermediate value then. Well, or we just repeat our table. Well, is a 4 distance... no, maybe it's a mirror. And we would not have to... Well, we might want to abs. We wouldn't necessarily need to mod, because our biggest distance could be... Abs takes out some of the cases for us. Don't have to worry about deal with negatives. So go 1, 2, 3. 4 is straight up opposite. And then going the other way, it would be 1, 2, 3. But if we were going here, yeah, that would be a flip, I think. This isn't quite as nice as the modulus. For one thing, this limits it to being exactly 8. And we have to consider all possibilities, which I mean kind of means we could do that. I guess, oops, since that's, we could, that might be a little bit clearer. Yeah, we still need you. So it's a little bit brute force for our exact size. But we're only dealing with 0.5, so we can just expand the table. All right, so now that we know how to do that, all right, that we can classify them properly, we actually want to draw some of these things differently. And figuring out exactly how and where to draw them might be the... Maybe there's a formula for like a circle connecting 2 points. Although you'd need the... I know what the radius is. I could probably even get some properties out from like the... working with the triangle of that line. All right, it's been a while. We might be doing some more experimental stuff here. Did I never get a source control up? Didn't. All right, so that's the... I should ended up down there. Okay. So we want to do some kind of... Oh, do you have arcs of circles? Ellipse, circle, rounded, 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 and gone. Oh. If you want support for curves and arcs. Does SVG support this? I know Canvas does. Oh, path. Well, I can probably bootstrap down to an attribute. Just going to have to calculate all this stuff myself. I don't know how that will interact with some of their scaling. But it would be a path. Line, segment. Yeah. Curves and arcs. Oh, all the path stuff. I don't know if I have any way to get this into into the system. Because Elm likes to do closed types. And this thing actually said it was looking for a maintainer, didn't it? No, this is... graphics. Yeah, that's the entrance. Well, no, actually, oh, there's already a newer version. HTML to have attributes. Okay, so this is the release notes. Update README. Okay, so that's a pull request. So we could pull it off locally, use it, and then maybe look at that's submitting that. Ah. Remove unused dependencies. Yep. Quite functional aspects. Add visor curves. Or was that a PR that got rejected? Which creates a path. Point path. Hmm. Okay, so he's moved off to other stuff. Ah, text measuring. Yeah. because that's kind of related to that. Separate arguments to styles and remove style alias. Canvas rendering. Well, let's at least look at the code and see exactly how much stuff is happening behind the scenes. Is it something we could just sort of literal in a path element, or is it going to be a problem? I could also see if there were some other SVG libraries. It'd be a big rewrite. Might be a good bit of context to have. I think Collage is using SVG. Well, we've got SVG too. Basis for HTML and particles, charts, charts, charts. Elm geometry types. Parser. Plotting, plotting. Serialize. Path constructor. Don't know which of these is primary. Parser and pretty printer. That's a lot of SVG stuff. This is okay. So we have the SVG package. We might be able to. Well, and this. Is there a way to import that in Collage? Path string. Yeah. So there's actually no help with that. Stencil shape. You have a type of collage. Are you trying to do app stuff? That might not be the right level of abstraction. Isosceles. Fraction of a circle. So float, float. So it's a stencil, which I think that means the same thing as your shape. So this is actually what we need. Filled, outlined, line types. This almost looks derived. Or one of the other ways. You have your own color thing. Rendering HTML. Okay, this is like Bizer. Slightly different names there. Move, rotate, scale, scale X, scale Y, mirror, skew. Different event system. You've got your own colors. Full transforms. Oh, this might mean some overhead on how we use it. Oh, whereas this one we were seeing app, LE app widget. Animations and functionality. I mean, maybe we want some animations, but I don't know if I. Is this my entire app? Inside Elm HTML. Model view update. View collage. It's still collage. Message model, model command message. Its own coordinate system and view. Model, widget state, widget model. Init your subscriptions, your update, your view. Which returns HTML. This might be. I mean, I could do the rest of my stuff in, like the footer and stuff in SVG. Might be a little bit weird to do page position placement. Maybe they got stuff for that. Oh, wow, this is like actually just syntax helpers. If you know SVG, which, I mean, that would be something. Work in progress intends to replace outlying SVG. So this is going to be at the same level of abstraction as SVG, but with better type safety, and it's work in progress. Okay, so this is slightly more explicit about what this stuff is doing. Arcs. I guess elliptical arc would be kind of what we're looking for. Okay, so there's SVG path, convert SVG path syntax into Elm data. Which then this could get put into the Elm SVG package. Pack edge. Okay, so that's what that is. Do I actually end up, I don't think I fully cloned this yet. Examples path.elm. Yeah, that's its point path. Well, that would be similar to what we'd need. Type path. Okay, there's a provision for a polyline type. List of point. That's going to interact with stuff that draws paths. Layout. Okay, so you've got a big old switch statement. svg.points. This is a render. Adders events. svg.poly. Okay, so you're going directly to svg.polyline, not the generic svg.path. So do you have a hook to generic SVG? It's color. That's collage. Oh, it lists on dependencies. And SVG's gonna SVG actually doesn't appear in here. Images in HTML. Well, we can put an SVG in HTML, and we can put an HTML in an SVG. It doesn't seem like necessarily the best way to do that, but it's a thing. But I'm not seeing a way to stick an SVG element into a collage. As an SVG element anyway. So we can fork it, and then maybe we could PR that back. That's the raw SVG if we had a way to put it in, which I don't think we do. What's the, it would have to be in the collage module, right? Doesn't even mention the SVG types. There's nothing there that has a type that will accept an SVG. They may have been intending, to have like the canvas renderer or whatever. So SVG is just an output format, so it's why you don't have the escape hatch. And this is an app takeover. Oh, yeah, you're very built in. I got to do some custom stuff for mouse wheels. What's your interaction model? Keyboard. Maybe you only handle keyboard? View title body collage. Oh, so those are like different types of apps. This is like the basic type of app. Oh, and there's also reference to those. So we've got lots of the shape stuff we need. I just don't know if I want your tick model. Oh, create an SVG from a shape. So I might be able to use the straight SVG library. Although maybe it still needs that for some stuff. The only thing about that, like, this is like a major conversion to switch libraries. Also, you have your own mouse functions. I don't know if you have a generic event function. I used to call them notifications. Notify tap, notify tap. Mouse enters, mouse leaves, mouse move, mouse down, mouse up, touch start, touch end. I guess I could go back to the window. I could get the SVG and wrap it in something else that got custom messages. Clip operations. Custom lined by, oh, okay, this is the line style thing. I see, what's the currency of this? 2019. Mouse coordinates broken in Firefox. Well, that's not a good sign for us. Mac Kaz McMasters. Twenty 2017. So we might be having to modify this as well. Okay. So I want you, for easier reference, we just have, we just got things here. So this might change my dependency structure a little bit. No, it is 3.0. Huh. Oh, it's probably source? Yeah. Basics.ecta. Are we only using one function in all of here? We use it once. Now, Elm does have the ability to strip unused functions from libraries, but still. I guess it's not a big library. Oh, a safe. Never crashed the app. Oh, is 0. Wonderful. Change how arguments are passed. This splits paired arguments into 2 separate arguments. And that's curry. Combines 2 arguments into a single pair. I mean, that's trivial. I mean, I guess it's technically beside the point of this library to define that, but list.map uncurry svg on. So it's a function of 2 arguments to a pair. So svg.on is the thing that takes 2 arguments. Can we bring up the svg library? Oh, so it's doing string decoder. Oh, it's getting. Oh, list.map, all of these things. I'd almost rather not have to think about the uncurry, what uncurry's doing anyway. Okay, so we are on a massive rabbit hole right now. I want to. There's a game called Hades. It has a whole bunch of gods you can get boons from. If we look up like Hades Wiki, we can go find an example. You get things like this. These are actually going to be semi-manual, but basically graph of lots of dependencies. And the duo boons, they didn't even try to do a chart of this. Oh, excellent. Let me bring up my semi-automated version here. This is output. So this was an attempt with automated graph layout that sort of gets there. Yeah, unfortunately, I think I just like finished up what I think is the last major story beat, so I'm probably going to be moving on. I might be back now and then, stream-wise. So this kind of gets the gist of it, but there's no organization to the duos. They're all over the place. This stuff is still confusing as heck. The hand-drawn ones are much better, and I think I'm going to have to use some form of hand-drawn anyway. So I have this. Where did I put? Did I just put it here? No, that was okay. That was intermediate stuff. Did I just do a work? Yeah, this was me playing around in Inkscape for how I want to run the duo boons, more or less. And there's a lot of like guidelines and things on here too. Yeah, I've pulled some data from the game so that I can do some degree of database stuff. Although, I mean, other than the duo boons, I probably have to do some manual layout. I can use that for icons and names and yeah, the like if I stay with these lines, this is going to be like you want to put an icon here, but now it's crossing this other line. Like, do you put it off to one side or the other? Maybe put it on both sides, but still, there's just a lot of crossing lines. But, plot twist. The library that I've been using for all of these line graphics has been pretty good so far, except it doesn't currently support the kind of operation you would need to do these partial arcs. So I was kind of looking around to see if there's other SVG libraries. There's one that's more like an app takeover, like educational playground thing that I'm not sure I want to deal with all the app takeover stuff. There might be a way to just get an SVG out of it, but it's got like some things it's expecting to deal with screen resizes and other things. I'm not sure that would be good. Trying it out would be a total app conversion. So I'm looking at forking the library I was using, and then maybe I can see about extracting some stuff later to PR back. To do those art paths, at least to the extent I need them. And first, I'm just trying to reduce, there's like a trivial dependency that it's like, do we really need that? And then this this would not need basics extras either if we were to do it by itself. Which means that you do not need basics extras unless we go back to the full library. I'm not sure who's pulling in time. File? I almost wonder if that's a leftover from something. Maybe from browser. So I should probably checkpoint that. And particularly if I PR it, I might want to... Or I might want to make that a separate PR, I don't know. Now the hard part. Okay. Well, thanks for hanging out. Yeah, it's kind of a. I don't know how far you are into code. So there could be a whole lot of levels of stuff to try and explain there. So collage is most of the interface. He's kind of got this grouped up. This would be a kind of path. Line segment paths, yeah, it would have to be traced to be... Trace does these, because these does these kinds of things, I believe. Oh, it just handles ASCII art, okay. Actually, didn't creating paths. This is to do this. Interesting. I mean, this is a straight up comment. Somebody else, please file an issue. Now he's saying arcs as part of Bezier paths. Now I was thinking circles, ellipses. Okay. Oh. Okay. Glad you enjoy it. I was thinking arcs, but I think a circle might be kind of a 2-point Bezier. Well, you have to have a path and a direction, or maybe it's like one control point. It would definitely be some kind of arc. I don't know if it would... I was thinking trying to do circles. Just for nice symmetry and things. I guess just an arc has to be part of some kind of circle, maybe? And what if it distorts? Okay, so the raw SVG, yeah, this is a arc. So this is a move, arc, line 2, arc line. Move to 100, 300. 100, 100. Oh, the sweep flags. This is like framework, and this is what changing changing this stuff. Oh, there's an inner circle here too. Huh. Oh, is this filling? Oh, move, arc, line, arc, line. Okay, so it's these lines. This is not like a big thick line. This is outlining the edges of this. Fill, stroke, none. Now he did polyline. We have layout. Handle points. Oh, because he has to measure the distance of things. Okay, this is local function, list.map. Just list.map. Maybe just bounds the points, which might actually be a problem for us trying to measure the outer bounds of it. Render turns it into an svg.polyline, which apparently is a different thing. Oh. Got a series of straight lines. But it's not path. Typically, polyline is used to create open shapes. Well, if I want to do a path, I would have to, well, I guess art could be a special thing. The bound calculation part might be the reason he hasn't done it yet. Oh, you know what? The other package might not have all the bound calculation stuff. You know, and relative position, which is why it was easier for them to do all these things. But we've got a type here. Oh, polygon and, well, one's a path, one's a shape. But interestingly enough, they're the same thing internally. I mean, it's actually core that defines the type. Oh, shape, no, polygon. Polyline. I was only searching for poly. So I could define just the arc, which I guess I could just say the bounds of the circle, which might not always be right, but would be simple. Now he had the intent to do this as full bisers. Calculating the points for that could be interesting. So we're going to need to be able to tell the underlying SVG. The center of the arc, which, do circles have centers, or do they just go with the current drawing center and you count on transforms? Oh, because these arcs can be part of this path thing. And I think the other library called it a wedge, which if you were to close it would probably be true. But maybe that would also stroke the lines in the path. Huh. What does circle have? Yeah, circle's just a radius. So we have an implicit center point. So we don't need that. X-axis rotation. Oh, so that's for irregular arcs, which is not what I want here. So I don't know if that's useful. It's not full utility if you're trying to do a general purpose thing. The large arc flag. I think that's if you specify a point, you can either go clockwise or counterclockwise. One means clockwise, the other means counterclockwise. Sweep flag. The sweep flag is that one. Which one's the bigger? They both have the same. No, they don't. They don't have the same center. How is that? Oh, is that like a start point? Point the arc is drawn to. So from here, well, I mean, 0, 50, 100, that would kind of make sense. And 100 to 100. Would it? I guess I don't know where 0 is in this graphic. Or does center point mean out and around and go both ways? I guess I need better documentation. So there's your full Beiser curve. So we could probably like calculate the tangents to make this work. X and Y radius. There are two ellipses that can connect at any 2 points. Oh no, this is X and Y radius, not center point. So this is going to be, we need to actually look at ellipses to understand this maybe. To end the stroke, where does it start? Do we just always start at a certain point and then end at a certain point and then it just, well, I'm not saying what this, maybe this is that example. Once again, what's the coordinate system? Oh, is this like move, move to 10, line to here, arc to here, line to here, arc to here, line to here? So the line is for illustrative purposes. This red line and stuff is not actually part of, unless it's a separate part of the graph here. So 30, 50, 30, 50. Okay, so the rotation parameter actually has something to do with the ellipse itself. Yeah, so that actually does rotate the entire thing. This would be irregular, this would be tilted, which we shouldn't need for regular circles. There's a 0 and those are both 0, 1. Goes diagonally across the page. They've been cut out. Left at 0. Negative 45 degrees. Unrotated ellipse in the image above. There are only 2 different arcs and not 4. Okay, so yes, it's current point to target point, this kind of ellipse, or an ellipse of this shape. This might not be the right kind of API. From point to point, this shape of ellipse. Well, and then there's drawing the circles and ellipses, which doesn't necessarily tell us how you. Well, it tells us which one this is. So there's our 0, 1. So I guess it's large and small. Remember seeing that in the other one. Oh, clockwise or counterclockwise. Well, we would one short and one long arc. The start endpoints are farther than the ellipse's x and y radius can reach. Expanded so it can reach the start and endpoints. Large arc sweep. Are none of these the things I would want? Or maybe this is if it's an arc that's all the way around, what do you do with it? Oh, or does this mean include the side points? Determines if the arc should be greater or less than 180 degrees. The flag determines which direction to travel on a given circle. Arc should begin moving at positive angles or negative ones. Which of the two circles? So we would, So in a path, you've got a current point. I'd almost want this to work more like a circle, which I guess you could take, move out to blah, sweep such and such amount of the circle. And we could probably arrange the path stuff to do that. Actually, does an SVG, not a collage, but an SVG, circle or ellipse just have these options? No, it's SVG path. Where did I put? It's collage. All right, I might want more examples, but I need to simplify. Circle. Oh. What does a raw SVG circle look like? Is it CX, CY, and R? How does that work? Or is that a property, not a... Does it calibrate the browser's distance calculations? Impute everything as if the path length was 90 use. Is that for like anti-aliasing and stuff? No, these are all... Okay, that's the... okay. So that has some scaling for... What is this? I guess H is like repeat for lines. So that might be affecting things for like dots and dashes and stuff. So no. Circles and ellipses don't have that as a built-in thing. Hmm. Do I want to now add a dependency on these? Let's path the graphic SVG. I guess it just falls under path. I didn't know if they had a simpler version of that than the full-fledged path statement. So how do I want to specify these? Well, I'm trying to connect 2 points. Interestingly enough, the arc syntax is actually pretty good for what I'm trying to do. Because I know my 2 points. We have line segments, which are kind of under path, but they're not. Oh, maybe segment is a kind of polyline? Okay, yep, a 2-point path. So this would be like a arc segment? Or arc would be, I guess the arc function would give you 2 points and, well, I guess you still kind of need to specify all that stuff, don't you? You have 2 points. From 2 points, you potentially have 4 circles, even if we don't allow ellipses. Or do we, I see, the weird thing is if we tried to make it act more like a circle, then it's one of our basic shapes. So they actually render very differently than a circle. Nope, wrong library. Paths can only be traced with, well, path. Okay, so loop is a closed path. So the underlying implementation is a path. I think in the canvas library you do arcs by adding parameters to a circle. Or maybe it's a separate function that's just very circle-like. Or maybe, do I just put in the SVG escape hatch? And then I can just do a path to my specifications in this application by whatever means we want. Well, how does HTML work then? I don't see that as a shape. basic, okay, it's a type of collage. So shape is that thing, path is itself. Groups and sub-collages. I guess those are the either dimensions or locations for text image HTML. Well, if HTML is in there, then some other raw SVG would be in there. What was I doing here? Oh, I was trying to do that. SVG.foreign object. Well, this is returning SVG, so this would be a drop-in. Oh, this is width and height from the looks of things. I guess it's generating its own names. The adders of the collage, the events of the handlers. I would have to put a group around it to get the attributes of this thing. And this is going through all the different types of shapes. Polygon, circle, ellipse, rect. Basic equals core dot path. Line path. Adders. Oh, for a path. Oh, yeah, all the options. So if I wanted to behave nicely there, it'd have to be in the library. I guess if we develop an SVG, we just add all little properties to it. If we just do the arc that we need, though, that's not really a general purpose feature. If we did a approximate a circle with cubic Bezier curves. Typos in the equations. Start and end points of the arc, the center of the circle, y2, x3, okay, x1, y1, x4. Oh, so it's 1, 2, 3, 4. So a general facility for Bezier curves would be a bit more general, would be a bit more useful. What does, and this is hopefully as it's spelled correctly, Bezier. Path visualizer. Okay, so this is nice for drawing, for just kind of fudging things out. I guess it's under paths. Do we have this open somewhere? Line commands. Oh, yep. Oh. The search for E doesn't match. The cubic curve. So I guess path cubic would actually be the curve commands. Okay, it could be Bizer, it could be cubic. And then my app would do the math for the control points to get nice circles. Because it is, well, it's a little brain bending to think what those parameters mean. That would just kind of be math. Yeah, I think my problem is I have a limited use case for arcs. So the things I would want to specify to make my life easy right now are not things that would be good for the library in general. Because I'm not really sure what the interface for the arc should be given other use cases. So let's just see x1, y1, x2, xy. Two control points for each point. 3 sets of coordinates are specified. Why 3? Where the line should end. Oh, so there's an implicit current point. So you would do a move to, and then do all of your cubic points. Yeah, shortcut. The quadratic curve is actually a simpler curve. It requires one control point which determines the slope and the curve of both the start point and the end point. The formula we saw before for calculating an arc suggested that we needed to calculate 4 points. I guess if you're going to do Bizer curves, you'd really want to implement both of these. We could do one for now. T. And arcs are just kind of... It's convenient when you're trying to do that, but it's also a little brain bending. Okay, so the more generic feature would be a cubic Bizer curve. Although, I guess the control points could be treated as the same way as a path, sort of, for layout stuff. Or do we call it cubic Bizer? Cubic curve. Now, this is a somewhat abstract representation, so this would have all of the points, and then its starter point is part of the path syntax. Now, whether this library would want to incorporate one of the other wrapper libraries, I mean, what we're doing here probably isn't too complex. There's examples. There's no direct test. It'll probably affect, oh, you know what? You know what? Yep. So we're going to have a whole bunch of things that no longer have implementations for this. So the first one it found, it doesn't have a file ID. Maybe because the resize threw it off. So the first one it's finding is in layout. So there's a thickness and a cap and a polyline. So for layout purposes, this probably does look an awful lot like a polyline. And then a render, which is going to be much more different. Okay, so the only reference to it, you had a much simpler implementation before. I guess we could put in this polyline thing as a way to just kind of start looking at the rest of the path. And then in collage, where we have path, well, it'd be like line segment, generic path. Well, I guess, and then maybe arc. You could have an arc function here, did all the math. And should we also be, oh, it's a, this really needs more description to be finished off. Oh, yeah, it's just list point. Maybe we call it cubic Bezier now. That shouldn't be a problem. And then making this exactly a certain arc is a problem for our app. Yep, that was it. We might want to, well, these are both going to be kinds of arcs. So those are the centers. That should all be figured out. We are going to have point, and I guess like a radius. What's the radius here? Center of, oh, it's going off the center of the circle. Point to point, which I guess gives you like an implicit radius. Hmm. I might need to style this differently. So this has to be the path. All right, and can we do just like segment from to syntax check that? Okay, so that types all check out. So you would do an arc. The center might feel like an awkward way to do this, but somewhere I'm going to have to do this math. Actually, if I did this as the center, which I don't know where the center is from here, because this is no, these are not local. We'll still get something. And then we have our math. Arcs less than pi divided by, 90 degrees. I might go over 90 degrees. Oh, the other thing we have here is that we have our, and I guess our library thing. This technically requires at least 4 points, which is actually a design consideration. It probably does something if you don't give it enough. And I'm not sure what that means to a cubic curve. Not that we actually have a cubic curve yet. Oh, I have to expose it. Oh, how about an actual list? Or I guess another thing we could do would be center. It'd be something, not something good, mind you. Yep, it's something. But that means we've kind of got code going all the way through somewhere. So I might be like kind of work this actually. Oh, except well, no, they're tuples, so they can just kind of pattern match. Don't have to have names. Uh, okay, that is floating point division. Maybe we have a square root function, but the syntax is going to be off. Well, we need to do this. I don't know if we're going to get too much better naming than that. So we just need a whole bunch of points. Okay. Given that we're not putting in the proper center here, this probably like gives some sense of where the actual curve is going to be too. We're probably actually going to have different centers for these, which is actually going to have to be a little bit calculated. So for a skip one, makes me even think of that. We would take point between there. So the midpoint would be one thing that might be interesting. Actually, can I see anything? I probably closed my one. No? I can't really see the circles these were drawn from. It might actually be somewhere around there. But that means we need to have references, more references to this. At that point, we could even do this because it's not as much. Is that just a function? So I can do all the breakout and recombining. Did I end up using this? I did not so far. Midpoint. So we have, well, XA, XB? Or no, YA? So what is this? This is... Would that be B minus A? Oh, yeah, that is A. It's YA. Maybe I'm calculating really bogus values for midpoint? That doesn't seem too crazy. Or, oh, maybe, is this the doesn't work for greater than 90 degrees thing? Well, skip 1 should be 90 degrees, I don't think. Was it like just over? No, actually negative, no, that's a small fraction. I think -5 could be a problem. That doesn't seem so bad. I guess it's going, I don't know if it's correct, and maybe that then is not working with some of the other stuff. So I need to find out how that's working. Does that make sense given its inputs, or am I doing it backwards? And then we have to do this to get the result. Oh, okay, there's different signs. That means it's different points. Oh, no, that does seem wrong. So x should be essentially 0. That's not even a sign error. How? That looks effectively 0. Oh, but we're adding this. Well, x is x at no, yeah, x should be about the same because they're effectively no difference. That's fine. So does this mean that my a and b are backwards for what we're doing here? That looks like it's not doing the divide by 2. Oh no, rather it's this much. Wait, this should be basically 0. Well, that is basically 0. That one seems okay. So what if... So we know 0, 0 is okay. This could be something with the math we did. Maybe the entire graphic gets messed up because things are just a little bit off. Okay, that caused a little bit of distortion. That's reasonable. Okay, so we do have things going a little crazy there. Some of these are reacting differently than others. Still, the other stuff isn't like too badly broken. That's, I mean, look like we might have a math error somewhere. That's definitely reacting differently than the X did. I'm not sure exactly which of the lines are... I guess it's like this line is kind of going this way instead of that way. Maybe that math isn't even right. So is that a Poseidon Zeus? I don't know. Let's see. I guess I could... Can I moderate this? Well, I need a proportional midpoint to do this nicely. Wait, is that any different at all? Oh, maybe it is. Maybe that was just too extreme of a point. We're only doing the skip one. So if we had a curve roughly following that guideline, that would not be far enough out. But midpoint itself causes things to go absolutely crazy. I guess I need a proportional interpolator. Oh, maybe it doesn't have a defined direction. So like we get a 0 in the math somewhere. So I need to do a proportional bump one way or the other to keep things in bounds. Oh, in. I don't know if there's a conventional name for this. Now I might have to flip things around here because this is no longer symmetric, and you're probably going to want like a factor of from 2. Also, no, if I do this in the second level thing, it'll be fine. All right, interpolate from midpoint a little bit towards that. I don't need to draw this right now, but oop. Wait, what? Oh, no, okay. Okay, so yeah, that's pretty close to a box. So that seems to be the right interpolation direction. And that might not actually need to be, well, we'll have to see where the actual arc goes. And you, well, let's start with that. Oh, that copied my color. Now it is going to be, I guess, maybe more than 90 degrees, but it's not blowing up yet. Might be okay for a first approximation. Now, to place the thing, so I need to figure out where that point is. But the entire thing is getting too big for our target size now. So somewhere along the line, we just knock this down. I guess that circle is about our approximate target size. You were kind of, we've got a radius here. Oh, and then we're using those to get the centers that display the other stuff. So actually, if we adjust that, then it should actually get this. Might need more than that. Oh. We might be able to let it go a little bit more than that. We need to see the final size to judge that for sure. Interesting that it's perfectly circumscribed, though. Okay. So we think we have points that make sense. This is going to have to be an SVG path. So is it just D? Path D. Oh, that would be an attribute, though. All right, so svg.d. You did a decode points. Oh, it is a string.join. Okay, we've never done any of that stuff. So that's going to be a very closely related, probably possibly even using that. All right, so we use U for everything after the head. So we need a start and a rest. We don't have a thing for point. Unless there is a separate decode point. I mean, I could just put it back into a list. you probably need B space. And I need the actual command, which is C. I have to get a little bit long. So that's a list with at least one element. Now I guess we could have an empty C here. Technically. And then anything else, it's an empty list. It's SVGD, decode. Oh dear. And he just didn't hit the one case that did it. Do we have a bare path here? We have some words that are bare path. Well, can we work around this? I mean, these are very, very light wrappers. Oh, those looked very different than their guidelines. Okay. Well, you know what? No, the guidelines were correct-ish. So this has to do with where we put our points, and hopefully we don't need to put them too far out. Okay, so skip one. We kind of want to get beyond the main gods area. Oh, do I need to actually interpolate this up the other way? I guess technically negatives would work here. And with 0 would just be your midpoint, which that is where things blew up. Maybe because it's okay, so that formulation doesn't work for this. Oh, that's what? Which version was that? Was that the negative? I guess. Oh, maybe I was off by one there. Well, it's pretty. Unfortunately, it's the wrong direction. Looking at that one, barely there. At the other one, I don't know if it's going to be able to get big enough. Yeah, it's already kind of out there. So this is that 90-degree thing. Some typos in the equations. Okay, well. Approximating circular arcs. Well, maybe we have to go back to arc. $90 degrees or less. Yeah. I need more than 90 degrees, it looks like. Because we're connecting over 2, so that's more than 90 degrees. So maybe we can't use a biser. Or, I mean, I guess you could... Could you automatically break it up? Yeah, that's still fairly short. Small circular arc. $90 degrees. Arbitrary position and size circle. It might just be that that's beyond what a biser curve can do. Where was the biser curve playground? I know we were in cubic. No. I'm not actually sure what the circular form's gonna look like. Well, I guess if you go beyond 90, you could theory. Well, we don't need to go beyond 180, but yeah, what would that even look like? We need at least one more point. How practical would we do that in automated fashion? would so I borrowed the math. So I don't necessarily fully understand the math we use to get the control points. We know the control points are like out here for some of these. Actually, it's probably like, no, you were more or less straight up. The other ones were hitting out here too. Probably like joop, joop, joop. Maybe the point where those come together is probably the limit of it. Can we figure out? Well, I mean, we've got 3 points. We can probably one of which is the center of the circle. So the distance from any of these points to the center is the radius of the circle. We would want to calculate. Well, we would have a center and 2 points, and we could calculate the there has to be a way to calculate the relative angle of those. If it's greater than 90, then what? You could midpoint them, and there has to be a way to calculate, and that gives us the radius of the circle, the intersection of the circle. That would give you another point and have the same center. If we used the same Beiser methods, we'd be duplicating some control points. There's the thing that does mirrored, but that means we'd have to have a library interface to doing that. And the awkwardness of all those different methods is probably why it hadn't been done yet. Or we make an arc method with all of its awkward stuff to describe all these circular properties. But the arc limitations here probably have something to do with why they had a dedicated arc operation. That would mean getting our head back into all the arc parameters. The arc parameters are like, was it radius x and radius y? Which I don't even know if I. It might have to be like an elliptical arc separately. And then for any 2 points, there are potentially 4 circles. Oh, well, here's a fun thing. One of them is described as winding direction. And we just kind of have 2 points. We don't know which way around the circle they are. We could figure it out. Like comparing indexes or something. Which would then have to deal with the wraparound again. I was just absing that before. I'm gonna need that midpoint anyway to draw the icon. So if we broke those up, and if that was still less than 180 degrees, which I guess if you wanted to do a circle thing like around that, that would be more than 180 degrees. But these are going across, that's less than 180, so you could do that as 290s. But I probably need to take a break. So collage. Still could probably use some, well, yeah, the arguments to Beiser could use some description. Ooh. What we have right now comes from here. Oops. Whip duo arcs using local Elm collage. All right, I might want to keep working on this at some other times, although I think I have. Well, I have groceries today. I probably need to start doing the all the reading on the different vaccines and stuff, so we can get that stuff done because it's available in my area. Thanks for watching. Thanks to support from subscribers. And that is what I'm usually on. I'm seeing if I have any other. Well, there's some web app programming. Which, I guess I wasn't doing a whole lot of super webby stuff. This is like mostly, ended up being a lot of geometry. But if looking for someplace cool to hang out, Sean the Best is doing some, probably more web app stuff. He says he's doing something on Vue. Looking for someplace cool to hang out? Someplace cool to hang out? Thanks for hanging out with me. Goodbye and until next time.